Okay, our objective in this lesson is to find the area and perimeter of various quadrilaterals. So, problem number one, we've got the square. Finding the area of a square is easy. You know, you can think of it as doing base times height, like any parallelogram. But for a square, the base and the height are the same thing. So it's really just going to wind up being 13 times 13, or 13 squared, which is 169. So that would be number one. Number two, the area of a parallelogram, again, is base times height. Okay, in this case, the base is 15, and the height is 11. Alright, so the area is going to be 15 times 11. Which is 165. Alright, so that's the area. But wait a minute, we were supposed to find the perimeter as well. So let's go back and do that. Of course, the perimeter is the sum of all the sides. So in that case, all these sides are 13. So it's going to be 4 times 13 will be the perimeter. So the perimeter is going to be 52 for number one. Okay, for this problem, because this is a parallelogram, and I think this is a bit of a mistake because they actually only marked one pair of sides parallel, but in order to do the problem, we really have to know that it's a parallelogram. So I think they were supposed to mark these sides parallel as well. Okay, so let's go with that. So if this side is 14, then this side will be 14. If this side is 15, then this side will be 15. Opposite sides are congruent. So when I do the perimeter, it's just going to be, 14 plus 14 plus 15 plus 15. So the perimeter here is going to be 58. All right, let's move on to number three. Okay, well, this is a rhombus. The formula for the area of a rhombus is 1/2 diagonal times diagonal. This works for a kite too, by the way. So let's see, do I know both diagonals? Well, the shorter diagonal is 6 because of 3 plus 3. And the longer diagonal is 12, 6 plus 6. Okay, so it's just going to be 36. So that's going to be the area. Now we need to find the perimeter, but to find the perimeter, we're going to have to do the Pythagorean theorem. Okay, for example, say if I call this side over here x. Okay, if I do my Pythagorean theorem, looking at this right triangle here, then I've got a squared plus b squared equals c squared. So 3 squared plus 6 squared is equal to x squared. If I take the square root of both sides, that's going to give me x equals 3 radical 5. All right, but this is a rhombus. So if that side is 3 radical 5, that means all of the sides are 3 radical 5. Okay? So that means the perimeter is going to be 4 times 3 radical 5. 4 times 3 is 12, so that's going to be 12 radical 5. So that is the perimeter. All right, let's go on to number 4. Trapezoid. The formula for the area of a trapezoid is 1/2 base 1 plus base 2 times height. Well, we have all of these things, so that means the area is going to equal 1/2 9 plus 17 times 14. So the area is going to equal 182. Okay. Now for the perimeter. To find the perimeter, I think we have to assume that these are isosceles, and that should have been told to us, but let's go ahead and assume that they meant to tell us these were isosceles. Now with that in mind, we see that this side right here is length 9. Let's go ahead and drop another altitude down like this. Okay, now with that in mind, I'm hoping that you can see that this is going to be 9 down here as well. So that is going to be 9. Okay, so if this distance is 9, imagine that if I took this away from the 17. Scribble that out. What's going to be left? In other words, if I do 17 minus 9, that's going to leave 8. So that means there's 8 left. Once I take away the 9, there's 8 left for this piece and this piece to be shared equally. So that means this has to be 4, and this also has to be 4. We have 4 and 4. Alright, it is time to do the Pythagorean theorem again, using 4 and 14. So this is going to be 4 squared plus 14 squared is equal to x squared. If I take the square root of both sides, that's going to give me x equals 2 radical 53. So if this is 2 radical 53, that means this is also 2 radical 53, because we're assuming that it's isosceles. Now we have enough information to do the perimeter. So the perimeter should be all 4 sides. So 9 plus 17 plus 2 radical 53 plus 2 radical 53. Okay, if you put all that together, you get that the perimeter is equal to 4 radical 53 plus 26. Okay, so that would be the perimeter. Of course, if I ever needed a decimal, that's easy to come up with. In this case, that would be 55.1. Alright, so that is how you would find the perimeter. Let's take a look at number 5. Okay, number 5 is a kite. Let's remember that the area of a kite is same as the area of a rhombus, 1/2 diagonal times diagonal. So in this case, one diagonal is 6 and the other diagonal is 7. So that's going to be 21. Alright, so that should be the area of number 5. Now again, for the perimeter, I'm going to have to do the Pythagorean theorem, but this time I'm going to have to do it twice. Okay, say if I call this x, doing the Pythagorean theorem on this little triangle, that's going to be 3 squared plus 2 squared equals x squared. If I take the square root of both sides, that's going to give me x equals the square root of 13. But there's two of those, yes? So that means that we will have the square root of 13 here, and we will have the square root of 13 here. Okay, but we also need to do the Pythagorean theorem on the other side. Okay, say if I call this x, well, now let me pick a different number. Say if I call this n. Okay, now I'm using this 5 and the 3, so my Pythagorean theorem is 5 squared plus 3 squared is equal to n squared. If I take the square root of both sides, I get the square root of 34. But there will be two of those, so I've got square root of 34 here and up here. Alright, so when it's time to do the perimeter is going to be radical 13 plus radical 13 plus radical 34 plus radical 34. Alright, it's just the sum of all the sides. So that's just going to be 2 radical 13 plus 2 radical 34. That won't simplify any further, so if I wanted an exact answer, that would be it. Of course, I could make it into a decimal if I wanted to. It would be 18.9. Okay, so that's number 5. Let's take a look at number 6. Alright, let's go for the area. Okay, this is a parallelogram, so the area is equal to the base times the height. However, we have the height, but we don't have the base yet, so Pythagorean theorem. So say if I call that x, then that's going to be a squared plus b squared equals c squared. Notice the 20 is the c, so this would become x squared plus 12 squared is equal to 20 squared. That's x squared plus 144 is equal to 400. Subtract. That's going to give me x squared equal 256. If I take the square root of both sides, I wind up getting x equals 16. Okay, so that means the base is 16. So now I can do the area. So the area is just base times height. So that's just going to be 16 times 12. So 192. Okay, so that'll be the area. Time for the perimeter. Of course, if this is 16 down here, then this is 16. If that's 12, then this is 12. So when I do the perimeter, it's just going to be 12 plus 12 plus 16 plus 16. And that turns out to be 56. So that would be the perimeter for number 6. What is next? Okay, number 7 is practically the same thing. I know that the area is going to be base times height, but I don't know the base, so I need to do the Pythagorean theorem. So if I do that, so I did a squared plus b squared equals c squared, x squared plus 9 squared equals 15 squared. That made 81, 225. I subtracted 81 from both sides. I got 144. Of course, now it's time to take the square root of both sides. And that's going to give me x equals 12. All right, so that tells me that this base is 12. So now I can go ahead and do the area formula. So the area is going to be 12 times 9. Okay, so which tells me that the area is going to equal 108. Perimeter, if that is 9, then this is 9. If this is 12, then this is 12. So as far as the perimeter goes, the perimeter is just going to be 9 plus 9 plus 12 plus 12. And that's 42. So that's number 7. Let's take a look at number 8. Number 8 is just like one of the problems we did before. A lot of Pythagorean theorem happening. Okay, we're going to have to do the Pythagorean theorem. This time we're going to need it to find this. So we can find the diagonal in the first place. So let's do that. Okay, if I set up this Pythagorean theorem, that's going to give me x squared plus 3 squared equals 5 squared. So that's going to give me x squared plus 9 equals 25. Okay, subtracting 9 from both sides. X squared equals 16. Take the square root. You get x equals 4. Okay, so that means this is 4. These two parts of the triangle are 4 and 4. Alright, so far so good. Now I have enough information to find the area. So remember, for a kite, the area is 1/2 diagonal times diagonal. Thanks to the Pythagorean theorem, I now have both diagonals. So the area is going to be 1/2. So this one diagonal is 15, 12 plus 3. And then, of course, the other diagonal is 8. So the area is 60. Now, for the perimeter, well, if this is 5, I know this is 5. On the other hand, I'm going to have to do the Pythagorean theorem again to find this length of one of these, the hypotenuse. So say if I call this n right now. Then if I do the Pythagorean theorem again, using the 4 and the 12, so that means 4 squared plus 12 squared is equal to n squared. If I take the square root of both sides, that's going to give me n equals 4 radical 10. So that means this is 4 radical 10, and this is 4 radical 10. Okay, now I can find the perimeter. So my perimeter is going to be 4 radical 10 plus 4 radical 10 plus 5 plus 5. Alright, 5 plus 5 is 10, so that's going to be 10 plus 4 plus 4 is 8, so that'll be 8 radical 10. So this would be the exact answer for the perimeter. Or we could do a decimal, which in this case would be 35.3. So you be prepared to give me a decimal or an exact answer, whatever I ask you for. All right, let's do number 9. All right, again, I think we're supposed to assume that this is isosceles if we're going to find the perimeter. We can find the area right now, though, can't we? Okay, so the area, remember, the area of a trapezoid is 1/2 base 1 plus base 2 times height. So that's going to be 1/2 7 plus 15 times 10. That gives us 110. Alright, now to find the perimeter, we're going to have to do some shenanigans, including making another altitude. Okay, realizing that if this side down here is 7, alright, if that is 7, then that means this is 7 as well. Okay, keep that in your mind. Now, if this is 7, if I subtract 7 away from 15, what's left? In other words, if I do 15 minus 7, of course that's going to give me 8. Okay, that means there's 8 left over for these two sides. So I'm going to have to divide that by 2. So I'm going to wind up with 4 and 4. So think about it. If I have 4 plus 4, that's 8, plus 7 is 15. So it makes sense. Alright, now I will have to do the Pythagorean theorem. Say if I call this side x. Okay, and of course this is 10. So I'm going to wind up doing a squared plus b squared. So 4 squared plus 10 squared equals x squared. If I take the square root of both sides right now, I get 2 radical 29. So that's going to be this side, but if we're assuming it's isosceles, it's also going to be this side. So 2 radical 29. So now I can find the perimeter if I want. Okay, so the perimeter is just going to be 15 plus 7 plus 2 radical 29 plus 2 radical 29. Alright, so that's going to be 22, and this is going to be 4 radical 29. So 22 plus 4 radical 29. That's going to be my perimeter. Or as a decimal, that would be 43.5.